Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In today's lecture, we will study the two important physical quantities, that is the speed and the velocity. Okay. So speed and the velocity are the two different physical quantities. One may consider that what is the speed or what is the velocity. Okay. Because they are having some different specifications in them, and that's why they are getting differentiated from each other. Either one may consider these two quantities as the same, but they are different. Okay. So for the first of all, we will see what is the speed. So when we change the position from the one point to the another, then the time goes on. Okay, that process will require the time, and when there is a change in position from one point to the another, with respect to that, the time is also changing. Okay, the time also changing. We may require it or not, but time will never stop. The time goes on. Okay, so that's why when we change the position from the one point to the another, in that case the time also required. Okay, so this is a very one important theory of space and time. When one changes the position from one position to the another, then at that time there is also the change in the time. Okay, one can be available at one position at one single time. He cannot be available at the two position at one single time. If it is a 12 a.m. now and I am here, and at the same time I cannot be in the another room. So that's why one can be at one single location only at the single time. Okay, even when you are talking face to face, then in that case, whatever I will talk with you, that my words will take some time to reach up to you, your ear, because the sound requires the 330 meter per second velocity. Okay, so whatever I am talking with you, that sound will travel up to you with the velocity of 330 meter per second, and after that you hear whatever I am talking with you. Okay, that's why whatever the phenomenons here, that's all phenomenons will require the time to make the change in position. Okay, so there is the change in position, there is a change in time, and that phenomenon we can also call as the traveling. Okay, if there is a change in position from one position to another, there is a change in time also, and if it is happening, then the object is said to be in a traveling. Okay, that object is said to be in a traveling. So when there is a traveling, there is a change in two phenomenons. One is the change in position. If we measure its length, then it is the one distance. Okay, whatever the path followed by that object during the traveling, if we measure it, the length of path, then it is the one distance, and whatever the time required to travel that length of path, it is the time. Okay, so when the object is changing its position from one point to the another, then it has to travel one path, that is, it has to cover one distance, and with respect to that distance he may require some time. So in physics, with respect to these two quantities, there is one quantity related, that is the speed. Okay, with respect to the change in a distance and with respect to the change in time, the speed is related. So how the speed is related? Because whatever the distance the object covered in a particular time period, that is, for that purpose one quantity is there, that is the speed. So how the speed is given? The speed is given as the distance covered in that particular time period. Okay, suppose we have to travel from the point A to the point B, this point A, this point B, and the time period for this is the 5 seconds. Okay, time period is the 5 seconds. Then what will happen there? If I told you that you will require the 5-second time period to travel from point A to point B, then it is calculated by the minimum time, and for that the minimum distance is, okay, so how is the minimum distance? It is the straight line. Okay, this straight line will be the minimum distance. Okay, so if I told you you require the 5 seconds to go from point A to point B, then how much is the speed? And for that purpose we have to divide this part into 5 equal parts. Okay, if we divide this into 5 equal parts, then what will happen there? Whenever you go for calculating the speed for that particular time period, then at that time you have to consider the very small time. Okay, you have to consider very small time. Suppose from A to here, suppose if I give the name C, D, E, F. Suppose from A to E you require the 1 second. If you require the 2 seconds, from A to F you require 3 seconds, and from A to B as per the given it requires the 5 seconds. So if you have to calculate how much time required to go from point A to point C, how much time required to go from point A to point D, then in that case you have to go for the measurement. Okay, you have to go for the measurement. How much is the distance there? How much is the distance from A to D? How much is the distance from A to E? How much is the distance from A to F? These all distances you have to count, and for that purpose you have to know how much is the time period required to cover that particular distance. And if you want to know the speed between these 2 points, then you have to go by one single formula, that is the speed is equal to, how can we calculate the speed? Speed is equal to distance upon time. Okay, speed is the distance upon time. Now here, what is the time here? It is either the time period or either the time. Which time we have to consider? You have given the time period from A to B. So in that case, you have to consider the capital T time period. And if you want to know the time period for its specific parts, like from A to E, how much is the distance or how much is the speed, from A to D, how much is the speed, then in that case you have to consider the part of that time period. Okay, you have to consider the part of that time period, and for that purpose you have to consider here the small t. Okay, you have to consider here the small t, because it is not the capital T, it is the part of the capital T, and combining this all small part of the time, we can go for the capital T. Okay, so this is about the speed and distance upon time. So in that case, if you have to travel from A to B, then the smallest way is the straight line path. Okay, smallest way is the straight line path, and as we know about the displacement, how the displacement is measured, it is the difference between the initial position and the final position measured along a straight line path. Okay, it is the difference between the initial position and the final position measured along a straight line path. So in that case, if this you are going by a straight line path, it is the displacement also. Then if you are going by another path, suppose you are going like one curve path and reach here at point B, okay, then in that case the distance will be different. Okay, in that case the distance will be different because it is a longer distance. Suppose this is the 10 kilometer straight line path, then this may be a 15 kilometer. Okay, this may be a 15 kilometers. So in that case you have to travel a more distance than the expected. But to travel the more distance, if you are taking the same time period, that is the 5 seconds, then in that case your speed is more. Okay, your speed is more, because if the time period is same, then in that case your speed is more. Okay, because if we have to compare the two vehicles, suppose the two vehicles are starting from the one point, from this point. Okay, these are the two vehicles. These two vehicles are traveling in a straight line path, and they are starting their change in position from this point, and they have to reach after some time period, suppose after 10 seconds. If we measure the distance traveled by this point, it is up to here, and for this point it is up to here, then how much is the distance traveled by the, suppose I name this as the point A and the point B. Okay. Then if we consider about these 2 points, then point A has traveled a smaller distance, but the point B has traveled a longer distance, but both are having the same time period. So we can say here that if we calculate the speed is equal to distance upon time. So which object have the more speed? Which object is having the more speed? It is point B. Okay, it is point B, because speed is directly related to the distance. Okay, the speed is directly related to distance, and that's why we can say here that the speed of the B object is more, because in the same time period of the 10 seconds it has covered a longer distance compared to the point object B. Okay, so whenever we have to go for the comparison of the two objects, for the comparison of their speed, what is the necessary? That they are having the same time period. Okay, if the two objects are traveling for the same time period and they are covering the different distances, then for the comparison of the speed, we have to, one necessary condition is that they are having the same time period. Okay, if they are having the same time period, then and then only we can compare their speed. Okay, and whatever the distance traveled by those two objects we have to consider, and if the distance covered by the any object is greater than the another object in the same time period, then that object has the more speed than the another one. Okay, that object is having the more time period, that object is having the more speed than the another one, and that's why we can say that the speed of that object is more than the another one. Here the speed of the point object B is larger than the point object A. Speed of the point object B is larger than the point object A, and that's why we can say here that the speed of the point B is greater than the speed of the point A. Okay, so this is about the speed. So how to calculate the speed? The speed is calculated by measuring the length of path traveled for the particular time period. Okay, and for that purpose, what is the length of path traveled? It is the distance. Okay, it is the distance. So in that case, we can say here that the speed is defined as the length of path traveled per unit time. Okay, length of path traveled per unit time. This gives us the speed, or you can say the speed is equal to distance upon time. Suppose the speed is given by the symbol V. Okay, speed is given by the symbol V, and distance by the small s, and time by the t. Then in that case, we have to consider that it is the, if it is the small v is the speed, is the distance is the s, and time is the t. So in that case, we can represent the speed with respect to these symbols. Okay, now from this we can say that the speed is the one scalar quantity. Okay, we can say here that the speed is the one scalar quantity, because to represent the speed we just have to know about its magnitude. Okay, we just have to know about its magnitude, because the speed depends upon the distance, which is also a scalar quantity, and to describe this distance we require only its magnitude. Okay, we require only its magnitude, and that's why the distance is the scalar, the time is also a scalar, so the speed is also a scalar quantity. Okay, speed is also a scalar quantity, so we can say here that the speed is the scalar quantity, and to describe the speed we just have to know about its magnitude. Okay, we just have to know about its magnitude. Now, what is the unit of speed? What is the unit of speed? From this formula we will get what is the unit of speed. What is the unit of distance? It is the meter. Okay, unit of distance is the meter, and the unit of time is the second. Okay, so the speed is having the unit as the meter per second. Okay, it is having the unit as the meter per second. Now, if we go here, what is the dimension of this speed? What about the dimension? We know meter is having the dimension as the length, and the second is having the dimension as the time. Okay, so it is the length upon time. So we can write here m raised to 0, l raised to 1, t raised to minus 1. Okay, what is the speed? Having the formula distance upon time, having the unit meter upon second, having the dimensional formula length upon time, and having the dimensions as the m raised to 0, l raised to 1, t raised to minus 1. Okay, m raised to 0, l raised to 1, t raised to minus 1. So by this we can say that the scalar is having these all the specifications, like having the formula distance upon time, the unit as the meter per second, then the length per time, it is the dimensional formula, and this is the dimensions m raised to 0, l raised to 1, t raised to minus 1. Okay, so we can say here that now if we go for a particular distance, suppose from A to B, then in that case either we have the same value at each path. If we follow the straight line path, then our speed will be different. If we follow the curve path, then our speed will be different. If we follow this triangular path, then our speed will be different. Okay, so as the distance changes, the speed also changes if we have to consider for the particular time period. Okay, so accordingly we can also say here about the speed that the speed is having the number of values for the particular time period. Okay, if we have to count the speed from the particular points, particular change in position, and we have the constant time period, then to cover that particular distance we may have the different speed, because the distance also changes as the path traveled changes. Okay, so we can say here that the speed may have the number of values. Okay, the speed may have the number of values. So speed can be a negative. Okay, either speed can be a negative. No, speed can never be a negative. It is not possible that the speed is a negative, because distance is never negative, time is never negative, so speed cannot be a negative. Okay, speed cannot be a negative, so that's why we can say here that the speed can never be a negative. Okay, so these are some specifications of the speed, that it is the having the formula distance upon the time, having the unit meter per second, having the dimensional formula length upon time, and it is given by m raised to 0, l raised to 1, t raised to minus 1. Okay, so we are giving these units in terms of the SI units. The speed may be in a kilometer per hour, or the miles per hour, or miles per second. Okay, as per the convenience of the location, there may be use of the practical units for the speed. There may be use of a practical unit. So we can say here that the speed may have the practical units like the kilometer, in yards, mile per second. Okay. So these are the some specifications of the speed. Okay. Which are the specifications? The first one is it can have number of values. Okay. Then second one is the always positive. Then third one is that it is the scalar quantity. It is the scalar quantity. Then fourth one is its formula, V is equal to S upon T. Then its dimensions, M raised to 0, L raised to 1, T raised to minus 1. Then what we can say here, the unit as the meter per second. Okay. Unit as the meter per second. So these are the some specifications of the speed and how to calculate the speed. Speed is the distance traveled, the length of path traveled per unit time. Okay, it is the length of path traveled per unit time. That length, if we measure, it may be in any shape. Okay, so as the length increases for the particular time period, then the speed increases. Okay, so these are the some specifications. Now we'll move towards the second quantity, that is the velocity. So the velocity is also similar to the speed, but there it is differentiated by some points. Okay, so how the velocity is different from the speed, that we will see now. Okay, the velocity. So what is the velocity? When any object is traveling a straight line path, then whatever that object traveled, that we have to count by the difference from the initial position and to the final position with respect to the time. Okay, how much is that object traveled, that we have to count, and with respect to that we also have to consider the time. Okay, so in that case, if we know what is the initial position minus final position, it is the displacement. Okay, it is the displacement. So in that case, we have to go for the displacement. Okay, so how we can know about the velocity? Suppose here is the one object. Okay, here is one object, and if I apply some force on this object, then it will get displaced by some amount. Okay, it will get displaced by some length. Then suppose it get displaced from this position to this position. Okay, suppose it get displaced from this position to this position. Then what will happen there? To calculate the change in the displacement, we have to calculate this length. And how to calculate? This is the final position, this is the initial position. Okay, this is the final position, this is the initial position. But what we have to consider, in which direction that object get displaced. Okay, in which direction that object get displaced, and also for the displacement, how much amount of time that particular object required. Okay, how much amount of time that particular object required, that also we have to consider. And for that purpose, we have to go for the another term, it is the velocity. That from this initial position to the final position, how much is the speed in that case. And speed, if we consider in terms of the displacement, it is nothing but the velocity. Okay, it is nothing but the velocity. So velocity is given as the ratio of the initial position minus final position upon the time period required. Okay, velocity is equal to initial, the final position minus initial position upon time period. Okay. Upon the time period. So for the calculation of a velocity, we require these three things. That is the final position, initial position, and the time period. So what is the final position and the initial position? It is nothing but the displacement. Okay, it is nothing but the displacement. So we can give here the displacement upon time. Okay. So for the velocity, what is the formula? It is the displacement upon time. So in the previous case, we have seen from traveling from point A to point B, when we travel by a straight line path, we can go by how much is the distance travel, how much is the path travel. For that purpose, we have to subtract the initial position from the final position, then we will get the value of the path traveled. And when we consider this as a one straight line path, then in that case it is a one straight line path, so in that case it is nothing but the displacement. It is nothing but the displacement. So how much is the time period required? If we have to consider that case, then our velocity will get measured. Okay, our velocity will get counted. So velocity is given by displacement upon time. Okay, velocity is given as displacement upon time. Now if we think about the unit of time, what is the unit of time? It is the displacement upon time. So displacement upon time, this is the formula. Okay, velocity is equal to displacement upon time. This is the formula, and from that formula we can go for its unit. What is the unit of displacement? It is the meter. Okay, it is the meter. And what is the unit of time? It is the second. Okay, it is the second. So what is the unit of velocity? It is the meter per second. Okay, the unit of the velocity is the meter per second. Now if we think about its dimensional formula, then it will be, what is the dimension for the meter? It is the length. Okay, it is the length, and second it is the time. Okay, the dimension is the length and it is upon the second, that is the time. Okay, so if we go for the dimensions, okay, in terms of the m raised to 0, l raised to in that type, then our dimension will be m raised to 0, l raised to 1, t raised to minus 1. Okay, m raised to 0 because there is no any consideration of the mass, l raised to 1 because we have to go by the length, then t raised to minus 1, that is the time. Okay, t raised to minus 1, that is the time. So here from the velocity, if we have to count the velocity, we have to go for its displacement, then we have to go for its time. Then if we go for its dimensional formula, then we will get it is nothing but the length upon time. So what is the formula? Dimension for the velocity, it is m raised to 0, l raised to 1 and t raised to minus 1. Now the velocity can only be measured only along a straight line path. That is, the displacement can be measured only along a straight line path from the final position to the initial position. So the velocity can have the only one value. Okay, the velocity can have the only one value. Now if we think about the signs for the velocity, okay, if we think about the signs for the velocity, then we come to know that the displacement can be a negative or the positive. So as the displacement can be a negative and a positive, and for the displacement we also have to think about the directions. Okay, for the displacement we also have to think about the direction. So that's why the velocity also we have to think about its displacement and the direction, that is its magnitude and the direction. So in case of a velocity we have to go for its magnitude and direction. So that's why the velocity is the vector quantity. Okay, the velocity is the vector quantity. Now, if we consider the mod of the velocity, then what about the, it is equal to the speed. Okay, if we take the mod of the velocity, then it is equal to the speed, because whatever the magnitude of the velocity, that will be equal to the speed, because whatever the time required from this point to this point, and for that purpose also we are counting the time. So what is the distance upon time? It is the velocity without considering the direction. The mod of the velocity, it is the speed. Okay, it is the speed. So if the change in position is along a straight line path, then in that case the velocity is equal to speed. Okay, in that case the velocity is equal to speed. Or the velocity is the negative, then mod of the velocity is equal to speed. Okay, so we can write down here the mod of the velocity is equal to speed. Okay, then the one thing is remaining, that the velocity is denoted by v, but for that purpose, as the velocity is a vector quantity, we have to show here one arrow. Okay, as velocity is a vector quantity, we have to show here one arrow. As the displacement also vector quantity, we have to show here its symbol with its arrow. Okay, its symbol with its arrow, and here just our time. So velocity is given as the displacement upon time, but time is scalar quantity. Okay, so we can represent the velocity in terms of the vector like v arrow, that is v vector v upon vector s upon t. And what is the unit here? Meter per second. Okay, the unit is the meter per second. So if we have to go by the straight line path, then in that case the mod of the velocity is equal to speed. Okay, mod of this velocity is equal to speed, and we are representing the speed with the small v. We are representing the speed with the small v. So in this case, which are the specifications of the velocity we have studied? First of all, its formula or its definition, that velocity is the change in the displacement per unit time. Okay, velocity is the change in the position per unit time. Okay, so in this case we have to go for the change in the final position and the initial position. We have to think about the difference from the final position and the initial position in a straight line path. So that's why the velocity is the displacement upon time. Then in the case of displacement, we have to think about its magnitude as well as direction. So as we have to consider both the terms, the magnitude as well as direction, we have to go by the, we have to consider this velocity under the vector quantity. Okay, velocity is the vector quantity. It is the vector quantity. Okay, then if we have to think about the next, that is what is the formula, the velocity is equal to displacement upon time, and as the displacement is having the unit of meter and the time is having the unit of second, then it will be meter per second. It will be meter per second. Then what is the dimensional formula? It is the length upon time. Okay, dimensional formula is length upon time. So what is the dimension given? It is m raised to 0, l raised to 1, t raised to minus 1. M raised to 0, t raised to l raised to 1, t raised to minus 1. That is the dimension of the velocity. Okay, so these are the some specifications for the velocity, and depending on this specification we can go for the similarities and the differences in the velocity and the speed. Okay, so as we know, there are some similarities also in the velocity and the speed, like its unit. Okay, unit is same, meter per second. Then its dimension, m raised to 0, l raised to 1, t raised to minus 1, and its requirement, that we require the two positions for the calculation of the velocity, that is the initial position and the final position. Okay, so these are the similarities, and we will see the differences also. Suppose velocity is the vector quantity, then the speed is a scalar quantity, or the speed can have the number of values, the velocity can have the only single values. These all things we will study briefly in the next lecture.